Hi all, this is Sai Siddhartha Parvatneni and I am going to discuss about our project Intrusion Detection System. Cyber attacks are nowadays are difficult to detect, so therefore we need a system that can learn the nature of the attacks itself and take the appropriate actions. So the main objective of this project is to train a system using algorithms such as logistic regression, naive Bayes, decision tree, random forest, gradient boosting using dimensionality reduction techniques such as feature selection and PCA to detect the various attacks. So the dataset which is used here is CICDS 2017 and 13 types of attacks for evaluate executed. So as the computer networks have improved and become more democratized over the previous decade, network architectures and topologies have become much more diverse. Wireless sensor networks and ad hoc networks have expanded non-linearly, resulting in self-sustaining networks that would be connected to the outside world or not. This is particularly true for the IoT networks. Security is more important than ever since the number of variety of threats which are growing. The network intrusion detection system detects the anomalies in the network before they become harmful. It monitors all the traffic in the real time for any unusual, fluctuating, or irregular behavior. So the various evaluation metrics used are the recall, precision, and accuracy. Shonatel proposed a network intrusion detection system based on a non-symmetric deep autoencoder technique. The final classifier is a random forest, which is made up of two NDAEs stacked on top of each other. Tang et al. Introduced the software-defined network intrusion detection system, IDS SDN. The IDS model was deployed on the SDN controller. It has several layers of buried information on its neurons. So they also discussed a network-based intrusion detection system on paper 9 on automatic decoders. They used the principal component analysis PCA to reduce the dimensionality and save just the most significant characteristics before sending the data to Absutita and colleagues. So Absutita and colleagues introduced a cooperative intrusion detection system that is particularly useful for identifying intrusions when the information is scarce. So they have used auto encoders with layered denoising. So finally, to categorize the binary data, logistic regression is used by Niaz with his coworkers. Dataset description. CICIDS 2017 dataset was used to implement and evaluate our proposed model. This particular dataset is taken because it contains all necessary criteria for reliable network intrusion detection. It covers a variety of network attacks that are generally not found in other benchmark datasets. A corresponding CSV file of the entire dataset has been provided and made use of for machine learning or deep learning applications. The dataset contains the data captured over 5 days, starting from Monday through Friday. Although it is captured for 5 days, each day contains a specific type of attack except for Monday. So the Monday captured data contains the normal traffic flow. So the attacks generally include DOS, DDoS, brute force, XSS, SQL injection, infiltration, port scan, and botnet. The dataset contains 78 features and corresponding labels are divided by each day. So here the data shape figure shows the number of rows as 2830743 and the number of columns as 79. The dataset for our data is of the shape which is discussed as before, and there are 79 features in our data set. We have just one feature with the missing values. The feature flow bytes has 1358 missing values in our data set. So these values are missing completely at random. So the missing values may be due to a technical fault during the data acquisition. So we replace the 1358 missing values with the median or the values. The reason for using the median is to replace the missing values so the data does not get skewed. In terms of dependent feature, there are 13 different types of attacks and one Benin flow. So in total, there are 14 different classes of the dependent features, which are the target labels. So after plotting the box plots, we came to a conclusion that as compared to all the other cases, the class Benin has a lot of outliers for all the features. DDoS, DOS GoldenEye, DOS Hulk, DOS Slow HTTP Request, and DOS Slow Loris have values scattered over a long range of values compared to other classes for most of the features. So here we have used the correlation matrix. So So the correlation matrix depicts the features of max packet length, and the packet length STD have a high correlation of 0.98. In the forward FWD packets and flow packets that are highly correlated with a correlation of 0.99, and the average backward BWD segment size and the BWD packet length mean are highly correlative with a high correlation coefficient of 0.96. The next will be continued by my friend Sairam.
Hello everyone, my name is Sairam. Coming to data pre-processing. Data pre-processing is a process which is used to transform the raw dataset into a clean dataset. In data pre-processing step, we first separate the dependent and the independent features. Next, we replace all the infinity values with 0 in our dataset. We then use minimum maximum scalar to normalize our dataset to values between 0 and 1. In the next step, we use label encoder to label encode the dependent features. Coming to dimensionality reduction. Feature selection using random forest classifier. Finding the features importance with the help of the random forest classifier falls under the category of embedded methods. At each node, the dataset is split into two buckets by the tree, with each having observations that are similar to one another and differ from those in other buckets. The top 20 features from the feature importance were considered for the training the model. Results. The results of the feature importance using random forest is shown in the figure 21 and 22. Coming to the figure 21. In this figure, the feature importance computed using random forest classifier is shown. Principal component analysis. The principal component analysis reduces the number of features in the dataset, but it maintains most of the vital information of the dataset. Moreover, by making use of principal component analysis PCA, the issue of overfitting can be significantly reduced as it removes the features with a very high correlation. The explained variance is the amount of variance in terms of percentage, which is attributed to each of the selected components. With the explained variance of nearly 98 to 99%, we have 15 principal components that can be used for model training. Coming to the figure 22, the principal component analysis results with the explained variance. The thicker line shows the cumulative explained variance and the multiple thicker lines shows the individual explained variance.
Hello, this is Mahita. So, coming to the model training, the dataset with 2830743 rows and 79 features was split with 80% of the data used for training and rest 20% for testing. The following two methods for reducing the dimensionality for training the model are used since too many features can lead to overfitting. So, feature selection through random forest, PCA through explained variance. Supervised machine learning models were used because they measure its accuracy through loss function and it keeps on adjusting until the error has been sufficiently minimized. So we have used six different supervised machine learning models: logistic regression, naive Bayes, decision tree, random forest, gradient boosting. So coming to the logistic regression, which is one of the simpler and easier models to train in the process of classification. But a limitation of logistic regression is that it could be very efficient only when the dataset has features that are linearly separable. Linearly separable data are very rare to find in real world scenarios. The train and test classification report using the 20 features extracted from random forest classifier are shown here, which is like 91% accuracy for both training and test classification report respectively. So naive Bayes, the core of the naive Bayes classifier is based on the Bayes theorem. It assumes independence among predictors. In a number of real-world scenarios, the naive Bayes model can be applied without accepting Bayesian probability or making use of any of the Bayesian methods. Naive Bayes is an uncomplicated process for building classifiers, models assigning class labels to problem instances that are depicted as vectors of values of features, where the class labels are drawn from some finite set. So the train and test classification report are shown in these figures, which has 61% of accuracy for the both. So there is a decision tree. This model works by transforming the data into a tree representation. One main difficulty in working with a decision tree model is that even a small change in the data will result in a rather huge change in the optimal decision tree. It is also not so efficient in predicting continuous values. The train and test classification report using the 20 features extracted from random forest classifier are shown here, which is 100% accuracy. And the random forest. This model uses the decision tree model for its prediction. One of the main cons of this method is that it is time consuming and much harder than other models. The computational resources required are also much greater. The train and test classification report using the 20 features extracted from random forest classifier is shown below. So the gradient boosting will be continued by Teja.
Hi, this is Teja Kolla. Now I'm going to discuss about the gradient boosting. Gradient boosting model was also examined. This model is widely recognized as one of the most potent ML strategies for predictive models. It has been shown to assist reduce variance and bias in machine learning models. The key benefits of this model are that is more accurate than previous model and that it can train faster, especially on larger data sets. The following is the train and the test classification reports utilizing the 20 features retrieved from the random forest classifier. After computing the future importance, these are the results obtained with a better accuracy and F1 score by the random forest classifier. These are the results of the 5 techniques by using PCA, principal concept analysis. We observed that the best F1 score and the accuracy are by the random forest. Here is the conclusion. From the results in the table 1 and 2, we can conclude that random forest outperforms all algorithms with the both dimensionalities reduced techniques. However, further selection using random forest works better compared to the principal concept analysis on train and test data. Random forest has an average F1 score of 0.881 and 0.821 on the train test respectively, and accuracy of 0.98 and 0.98 on the train test respectively. These results depict that to perform detection of attacks, we can leverage random forest. These are the references we used in our project, helpful for to get the information. Thank you.